When we think about being single-homed, the issues are very clear. We have a single point of failure. That single point of failure could be the cause or caused by a link failure, a router failure, a failure of the ISP, and that is a lot of dependencies that we want to remove to have connectivity to the internet. We want more than just one internet connection. And if we are looking at just one internet link, BGP is not relevant. Why? Because we can get by with default routing. That's something that we would want to understand. It's okay in some places to have a single internet connection, but would we have full routes and a BGP relationship between us and the ISP at this point? Absolutely not. We may find ourselves with a single internet provider. That doesn't mean we can't have any redundancy. We may find ourselves in a situation where we just have one customer edge router, that's us, a CE router, and one provider edge router. Well, we could have multiple links. That would mean that we would be immune to an interface failure or a link failure. So it would have to affect, but it would really have to affect an entirety of a router in order to be affected, or the ISP could have a routing issue. We could be plugged into a situation where we have one customer edge router with multiple points of presence, or provider edge routers. This helps us eliminate one of the single points of failure. In this case, both routers are points of failure. And on the far side, we add additional routers. This is a much better option, quite frankly. We would choose to avoid circumstances where we have a single router that could spell the demise of all of our internet connectivity. And so we are still connecting up to the same ISP, but we've removed a lot of the possible points of failure, and this is a really good thing. And by the way, we may still run Border Gateway Protocol between us and the same ISP, and we can do things like the multi-exit discriminator or the MED to influence how traffic is going to come in, and we'll draw that with an arrow, come in to our environment. And we can also control how we leave and go into the internet. Those are the sorts of things that BGP allows manipulation of. When we are dual-homed, which just means two connections to the same ISP, a little different than multi-homed, which is different ISPs. When we are dual-homed, our autonomous system needs to know about the exit strategy that we have provided for it. We have to have an exit strategy. And in this case, static routing could accomplish that. Now, usually what we do is we use static routing just at the edges, and then we might redistribute that into EdgeRP. So redistribute static default route into EdgeRP. That's a common scenario. We might also do the default network command. How do we advertise the dynamic default route in OSPF? Default information originate. Border Gateway Protocol potentially, although that would be something we'd want to be very careful with. First hop redundancy protocols can also provide us some redundancy to the customer edge routers if we need to. Let's just say if we need to do that, it's potential. Now, how do we deal with routing between us and the provider? A default route could potentially be used. Default routing, even in a dual-homed environment, isn't necessarily a bad thing. It means we don't have to worry about running BGP. But if we need to control our connectivity to the internet, control really means we're probably going to need to run Border Gateway Protocol so that we can work with the attribute manipulation between us and the provider to influence how traffic comes in and leaves our autonomous system and influence which links get what traffic. That's the sort of thing that we can manipulate with BGP. let's say we have EIGRP as our IGP, our interior gateway protocol, the one that we use to get around our own autonomous system. How do we do default routing? Well, we would have our customer edge routers with a default route, default static route specifically, and then we like to redistribute that into EIGRP. So they've got a great example for us. We build the default static route, use whatever next hop IP address we need to, go into our EIGRP setup, redistribute static, give it a metric because we need a seed metric for EIGRP. And in this case, we are also giving a bandwidth and a delay to the seed metric. More specifically, bandwidth, which is larger for ISP1, which is going to be what is accounting for the traffic that we see illustrated here, because we are choosing different seed metrics. And in this case, we're saying this is, it's weird because usually when we think about a metric, a higher value is a bad thing. But what we're doing is we're putting in bandwidth and delay, so we have a higher bandwidth. So that's the interpretation of this, just to make sure you've got the right interpretation of the numbers. But in any case, this is going to advertise a dynamic default route into your autonomous system. And so the rest of your EIGRP routers will understand the exit pathways and will, in fact, be able to choose the best one for wherever they are in the autonomous system.